The next concept we're going to cover is acceleration, and in order to do that we're actually going to refer back briefly to the previous graphs that we looked at in the last video, and the reason for that is that there's a key point that we need to make. So in those previous graphs, the gradient of those graphs, if you recall, the gradient of a displacement versus time graph is the velocity. At some points it changes instantaneously. And by that I mean that at one point in time the gradient, if we just go back and have a quick look, so if you look at the graph here, so at this point in time here, 14 seconds, prior to 14 seconds, so this way, the velocity is 0, then at 14 seconds it instantaneously changes to a value of whatever we calculated down here, 1 meter per second. So there's a rapid change from 0 to 1. Now in reality that doesn't happen. So that change usually will occur over a period of time. So change in velocity will occur over a period of time rather than being an instantaneous change. And so the quantity that describes that change is acceleration. So with a change in velocity, so with the quantity that describes that change in velocity is the acceleration. Now rather than talk about how we define it and all those sorts of things, we're just going to, same way that we did with speed, distance, all those sorts of quantities, we're just going to jot down a few notes about acceleration. So acceleration uses the symbol A, and it is a vector. We'll talk about that in a second. The first thing is, the easiest way to think about acceleration is that it's the rate of change of velocity over time. Or with respect to time. As I said, it is a vector quantity, so the direction of acceleration is important, and we'll look at a few different scenarios where that occurs when we go through and do some questions. Easiest way to think of it though, if it's a positive acceleration, that basically means, or sorry, positive or in the forwards direction, that basically means that the object is speeding up. If it's a negative value, and negative usually means in the reverse direction or in the backwards direction, either of those two, means that the object is slowing down. So its velocity is decreasing, it's still moving forwards, but its velocity is decreasing. There's another term that we'll often use to describe that sort of acceleration, it's a deceleration. So a deceleration is actually a type of acceleration, it's just that it's slowing down. There's another type of acceleration that we'll look at in subsequent units. I'll just mention it now. We can have an acceleration that causes a change in direction. So the first two, positive and negative, is about whether the object is speeding up or slowing down in a given direction, but an acceleration can also cause a change of direction. The units of acceleration are meters per second squared. So the notation that we use for that is ms to the negative 2. Another way to think of it that will hopefully make it a little bit easier to understand acceleration is that it's a change in the velocity, so it's meters per second. Now I want to just develop that idea just a little bit further. If we had a car, let's say a car accelerates from traffic lights. So initially it's stationary, and it has an acceleration of 5 meters per second squared. So that acceleration basically means that every second the speed of the car is increasing by 5 meters per second. So the reason why I'm going through this explanation is to draw your attention to how to interpret acceleration. Being able to substitute it into equations is great, but it's important to be able to have a really good understanding of what the quantities actually mean. So in this case, 5 meters per second squared, every second the car's speed increases, or the car's velocity I should say, increases by 5 meters per second. So after 1 second, its speed, sorry, I keep saying speed, its velocity is 5 meters per second. After 2 seconds, it is 10 meters per second. After 3 seconds, it is 15 meters per second. And eventually that car will reach a speed limit, and at the end, if you just sort of think about it, the acceleration will then relatively quickly decrease to 0. And once it reaches the speed limit, the acceleration drops to 0 and the car will then continue to move at that speed. The last note here then for this video, generally speaking, we are going to consider that acceleration is a vector. Sometimes though we don't really care about the direction. And basically, as is the case with any vector, if we only are noting what the magnitude is, then we talk about just the magnitude of that quantity. So sometimes we are only concerned with the magnitude of the acceleration. And not so much its direction. And an example of that would be, say, circular motion, where the size of the acceleration is the important thing, because the direction of the acceleration actually changes as the object moves around a circle. But we'll get onto that when we get to the circular motion unit.